Imagine a factory floor where massive steel presses shape metal with incredible force, while nearby robotic arms move rapidly and precisely, picking, placing, and assembling components at high speed. Behind these motions are two invisible power systems that dominate industrial automation: hydraulics and pneumatics. At first glance, both rely on fluids flowing through pipes, valves, and actuators. But beneath the surface, they are fundamentally different technologies, each chosen for very specific mechanical reasons. Understanding why industries select hydraulics in some cases and pneumatics in others reveals a lot about how force, speed, control, and efficiency are balanced in modern engineering. Hydraulic systems operate using incompressible fluids, almost always oil. Because liquids do not compress under pressure, any force applied at one point in a hydraulic circuit is transmitted almost instantly and almost entirely to another point. This principle allows hydraulic systems to generate extremely high forces with relatively compact components. In an industrial press, for example, a small pump can create pressures high enough to produce many tons of clamping or pressing force at a hydraulic cylinder. This makes hydraulics ideal for applications where power density is critical, such as metal forming, injection molding machines, heavy construction equipment, and large industrial lifts. Pneumatic systems, in contrast, rely on compressed air, which is a gas and therefore compressible. When air is compressed, energy is stored as the air molecules are forced closer together. When released, this energy expands the air, creating motion. Because of this compressibility, pneumatic systems cannot achieve the same level of force or positional accuracy as hydraulics. However, they excel in speed, simplicity, and cleanliness. Pneumatics are commonly used in packaging lines, assembly automation, food processing, and electronics manufacturing, where fast, repetitive motion and clean operation are more important than raw power. One of the most important differences between hydraulics and pneumatics lies in force capability. Hydraulic systems routinely operate at pressures of hundreds of bar, allowing them to generate enormous linear forces through cylinders. Pneumatic systems usually operate at much lower pressures, often around 6 to 10 bar in industrial environments. As a result, pneumatic actuators are typically smaller, lighter, and faster, but they cannot handle heavy loads. This is why you see hydraulics moving heavy machine tools and structural components, while pneumatics handle lightweight parts and rapid cycling tasks. Control and precision also differ significantly between the two systems. Because hydraulic fluid is incompressible, hydraulic actuators can be controlled very precisely in terms of position, speed, and applied force. This makes hydraulics suitable for applications where smooth motion and accurate force control are essential, such as CNC machine clamping or synchronized lifting systems. Pneumatics, due to air compressibility, tend to be less precise. Movements can feel springy, and exact positioning is more difficult without additional sensors and control systems. However, for simple on-off motions, pneumatics are often more than sufficient. Energy efficiency is another key comparison point. Hydraulic systems can be highly efficient when designed correctly, especially for heavy-duty continuous operations. However, they require pumps, reservoirs, filters, and cooling systems, which increase complexity and maintenance requirements. Oil leaks, while manageable, are a constant concern in hydraulic installations. Pneumatic systems, on the other hand, use air, which is freely available and clean, but compressing air is inherently inefficient, and a large amount of energy is lost as heat during compression. Leaks in pneumatic systems are also common and can significantly increase energy consumption over time. Maintenance and environmental considerations further influence the choice between hydraulics and pneumatics. Hydraulic systems demand careful fluid management, including regular oil changes, filtration, and monitoring for contamination. Spilled hydraulic oil can pose environmental and safety risks, particularly in food or pharmaceutical industries. Pneumatic systems avoid this issue entirely, making them attractive for cleanroom environments. However, they still require maintenance of compressors, dryers, and filters to ensure clean, dry air, as moisture and dirt can damage pneumatic components. Safety characteristics also differ. Here is why. Hydraulic systems store large amounts of energy under high pressure, and failures can result in sudden, powerful movements or fluid injection injuries. These are very serious. Pneumatic systems generally operate at lower pressures, making them safer in many applications, though uncontrolled air release can still cause hazards. Because of this, Pneumatics are often preferred in environments where human operators work closely with machines. In practice, modern industrial systems often combine both technologies. A single production line may use hydraulics for heavy pressing operations and pneumatics for fast handling and positioning tasks. Engineers choose between hydraulics and pneumatics not based on which system is better, but on which system best matches the mechanical requirements of force, speed, precision, cleanliness, and cost. Ultimately, hydraulics represent controlled brute strength, capable of moving massive loads with precision and stability. Pneumatics represent speed and simplicity, enabling rapid, repetitive motion in clean and flexible systems. Understanding the strengths and limitations of each is essential for anyone looking to truly understand how industrial machines work behind the scenes.